for now, the integration questions, in some senses, all you need to be able to recognize is this. That the derivative of sine inverse is, come on X1, you just did this morning. 1 over? Okay. This doesn't look like what I derived earlier this morning. Let's try that again. 1 over the square root of 1 minus x squared. Much better, okay. Now, cos inverse obviously is almost the same. What's the difference? Minus. It's just negative. Tan inverse though does look different. Tan inverse is different in two ways, namely no square root and it's a plus, so you've got this. Right. Now, I think that's all we need to try and proceed and do questions like this. Okay, now, integration by parts, which we've been looking at, is not quite, well, this is what we established, not quite the reverse product rule, because you can use it on things that are products, right? So just let's quickly rehearse. What is integration by parts? What does it start with? U dv, right, equals uv minus integral of v du, okay? So you can start to, you get used to it. I find that by the time I've written this is an easy bit and this is just the other bit. That's how I think about it. Anyway, I now need to select some appropriate functions to be u, dv, etc. Okay? So I'm going to draw up my box. I'm going to have my primitives on this side and my derivatives on this side. So I need a u and I need a dv on dx. Right? Now, just like with log x, this is not a product, but we can make it a product. Right? So if we consider one of the functions as 1, what should we do here? Now, remember, it makes a difference which one you pick, doesn't it? Okay. So what you want to do is pick a function that here, when you differentiate it, it's workable. And here, when you integrate it, this product here will be workable, right? Now that locks you in quite quickly, doesn't it? Okay? Because obviously you can't put sine inverse here. Because then you'll say, oh, so to go to this box, I'll have to integrate it. Oh, right, that's the question, okay? So therefore, you're starting to get a sense of which ones you pick. Obviously, over here, I'm going to put the other function, 1. Okay? So that means sine inverse is here, and we can fill in the rest of it, can't we? Okay? Du on dx, this is this result which we've just shown. And that would make v x. That's good. Okay, right. Let's crack this thing out of the box. U times v, just on the left-hand column. I'm going to go downwards. That's going to be x sine inverse x. Okay. Then v du, that's this by this. Can you see how it's going to work? Can you see it? Doesn't look very nice, but the integral of x on the square root of 1 minus x squared. Okay, what's this thing going to be? What's this going to be? What kind of pattern does it fit? Is it f dash on f? Is it f dash on f? Well, that would make this denominator, f, that's 1 minus x squared to the power of a half, right? So what would be the derivative of 1 minus x squared to the power of a half? Well, I guess the power would become negative a half, and then you can do chain rule. That doesn't look like f dash to me, but it's close, right? How am I going to use this? What is this thing? Maybe if I write it out a little differently, it will help. Let's have x sine inverse here, okay? Here I'm going to write this as, how shall I do this? Let's do it like this. If I have the integral of negative 2x, so I had made that a plus, so I should make that a half. Is that okay? I've changed the sign, I've changed the number. Then I've got this, 1 minus x squared to what power? Negative a half. Okay. So this is not f dash on f. What is it? It's just a function raised to a power, isn't it? This is just reverse chain rule for, you know, that negative a half. It could be like -3 or 5 or whatever. Okay. Now, if you're struggling a little bit at this point, right? You're like, nah, too big for my brain, going too fast. Okay. That's a sign for you that you need to do the full substitution that reverse chain rule requires, right? You'd say something like, let u equals. Now, you probably shouldn't pick u, should you? Because we've got u's already. So maybe you make it w, okay? What would you choose? What would be an appropriate choice? 1 minus x squared would do it, right? Then you've got w, you've got dw on dx, which is that negative 2x that you've got there, right? Should we just proceed with this now that we've made the substitution? That way we know we'll get it right. What's going to happen here? I've got this a half out the front. Negative 2x will become, what's it going to become? Just dw, right? Once I get rid of these two together, yes? So that's going to be dw. And then 1 minus x squared is just w, the power of minus a half. Oh, I think we can do that. I think we can do that. Okay? And of course I have my x factors, sorry, my x terms out the front there. Plus, when you integrate w to the power of minus a half, what do you get? X sine inverse. What happens? You raise the power, don't you, by 1, which becomes w to the power of a half, and then you divide by the new power, don't you, which is a half, which means that. Is that right?
Yes.
Yeah, good. And I've integrated, so I better stick my constant in. Okay. All right, what was w again? It was that. So x sine inverse plus the square root of. Cool. And of course you could check it by differentiating if you like, but I'll just tell you in advance that's correct. Okay. So I don't know about you, but I just feel like it's integration by parts. It's kind of like magic. It takes something which you're like, where do I even begin? I don't know stuff about this. So, well, the answer is you do. If you know how to differentiate it, you know a tremendous amount if you rearrange it the right way.